Today we're going to be solving Leetcode question 129, sum root to leaf numbers. This is a very typical tree problem which can be solved by recursion. It's also a perfect medium level problem. What we are supposed to do in this question is we are supposed to find all numbers that can be formed by following a path from the root, starting from the root and ending on all leaves, and we are supposed to sum that up and return the total sum. We are supposed to sum up all the numbers that can be formed by these paths and return the total sum. Now we are going to solve this using pre-order traversal, in which you inspect a node first, then go to its left child and then go to its right child. If while inspecting a node we realize that this node is in fact a leaf node, we know that we have formed our number, and now we can add this number to the total sum. That's about it as far as the concept of the question goes. I'm going to use a string concatenation method to form the number, and when we finally reach a leaf node, when we know that we have found the number, like there is nothing left to explore, so we would have found our number. I'll just convert that string into an int and add it to the total sum. I think the question and the solution are pretty straightforward. So I'll get right to it. You can start coding. I'm going to write a helper function here. Sum of paths, which will need a reference to the node that's passed in, and we'll need a reference to the, so we'll be continuously forming a number, right? Like as we traverse down the tree, every recursion branch will correspond to every number that is being formed, and while that number is being formed, this current number will hold the intermediate string that is being concatenated to form the final number. Cool. So that's a string, and we will also have a total sum which we will pass by reference, which will be continuously updated by all the I'm passing it by reference so that one common variable is updated by all branches of recursion. Now since we are doing pre-order traversal, let's just unwrap this safely. What For people not familiar with Swift, this is just me. This is just a null check for tree node, which can also be null, right? So this is just like making sure, this is just a safety check to make sure that we don't proceed with the function until we are sure that the passed in tree node is not a null reference. Okay? It's just a null check, to put it in simple words. So if it is a null, if the node does not exist, we're just going to return from this function. It's a void return function. So since this is a pre-order traversal, we'll process the current node first. What I mean by processing is we'll actually concatenate the current node's value to the string that is being formed. Okay, so what would be the new number? What would be current? Actually, this can be a let, because this won't change. Current let is basically used for forming constants in Swift, and we'll concatenate the current node's value. Yeah, so we we could have, now we have formed the number using the current node's value. Now there are two possibilities: either that this is a leaf node or it is not. If it is not, we will pass this string that we have formed to its left child and also to its right child, right? Because both branches will form two different numbers which would eventually have to add to the total sum, or either that, or maybe this is a leaf node, and if it is a leaf node, then we need to add it to the total sum. The number that is formed now by including this current leaf nodes uh, uh, value to the number that was being formed, we have to include that in the total sum. So I'll just check if this is a leaf node, and if it is, so how do we verify if it's a leaf node? If its left and right child are both nil. If that is the case, we will add to the total sum, and since this is a string, I'll cast it to an integer and force unwrap it. Now, force unwrapping is usually not safe, but we are sure that the tree only contains numbers, and which is why we can be sure that force unwrapping it will not throw an error. For people not familiar with this, it's okay. Just remember that I'm casting the string to an integer. And that's it. And yeah, so if we have reached a leaf node, we don't need to, like, there's no point in passing it to the left and the right child. So and if it is not a leaf node, it will not enter this if at all. It will just go ahead and pass the formed number to its left and right child. Yeah, this is the number that is currently being created. This is the left branch of recursion, and I will pass the total sum by reference. This ampersand is for passing by reference. Again, ignore this if you're unfamiliar with this. This is not an important detail. I mean, it is an important detail, but you would be able to figure it out in your own programming language how to do that. And this is the right branch, and that's it. Not, I mean, that's not it. This is the helper function. Now, okay, again, I'll just put in a null check, so that the tree if the root itself is null, we just return a 0, because that would, we can't sum up anything on an empty tree. Creating a total sum, which we will return eventually the total sum variable, and now calling the sum of parts helper function, which only updates total sum. It's a void it's a void return function, but it basically updates total sum. So we pass the root, we pass an empty string, we because the because it would have to start with an empty string. Then the root will take the empty string, it will concatenate its value, it will pass that to its left and right child. The left and right child will concatenate their values, and eventually it will go to a leaf node where the final number will be formed, and we'll add that to the total sum. Sorry if my voice sounds weird. And we just pass total sum. Yeah, now I can say that we've completed the code. Yeah, that works. I hope I did a good job in explaining that problem. The thing is, there wasn't much to explain in this problem. It is a very typical tree problem. It is actually a good place to start solving tree problems if you're not comfortable with them. It's a very typical problem. Cool. Happy coding, guys. Have a good weekend. Actually, the weekend's ending, but okay. Bye. Have a good weekend.